our, I just want to give you a basic introduction about embedded systems. Because in this class, actually, we will focus on um, Raspberry Pi. Okay? So the first chapter, we will try to get familiar with Raspberry Pi hardware. Okay, so um, okay, so there are several types of models for Raspberry Pi. Okay, so Raspberry Pi platform board. Here we have three examples. We have Pi Zero. So you see, Pi Zero is a very small board, and then we have version 2 and version 3. Actually, right now on market we have version 4. Okay, so we have Raspberry Pi 4. Okay, but for our experimentation, because right now we have version 3, we have RPI 3. Okay, so most of our experiments will be using RPI 3. Okay, RPI 4 is the newest board, but it's okay. We can still use our RPI 3. Okay, so you can see actually RPI 2 and RPI 3, they are from the layout is pretty similar. Okay, but RPI 2, it doesn't have the Wi-Fi module. Okay, RPI 3, we have the Wi-Fi module. So starting from Raspberry Pi 3, we can connect the we can connect the Raspberry Pi to internet without using a cable. Okay, but RPI 0, you can see it's a very compact system. So it's very comparing to RPI 2, RPI 3, it's very small. So that means you can use this board to make a very small system. And so it's very useful for building embedded system to support certain applications. Okay. So there are several general characteristics for RPI devices, for Raspberry Pi devices. So all the Raspberry Pi devices, they are low-cost devices, and they are very powerful computing devices, even though they are very small. I have an example, for example, this. I don't know whether you can see, this is the Raspberry Pi 3, and we will use this for our class. Okay, so you can see this is the size actually is pretty small. This compared to my hand, it's very small. Actually, even though it's only a single circuit board, if you know the motherboard for a personal computer, you will know the size for Raspberry Pi is really small. But actually, even though it's so small, it is a real computer system. Okay, it's considered as an embedded system. When we say embedded system, that means it's designed for it's not that powerful comparing to general purpose computer, but most of the time embedded system, they are designed for special purpose. Okay, but however, Raspberry Pi is a general purpose embedded system. Okay, so it give us a lot of advantages for using Raspberry Pi. Okay? And the range of models that are suitable for different applications. So you see we have Pi 0, we have Pi 2, Pi 3, and now we have Pi 4. Okay, so for different applications, for example, if you have a very simple application, then you can use Pi 0. If you have a complex application, then you use those advanced models. Okay? And it supports many standard interfaces for electronic devices, because Raspberry Pi is a computer system, so it supports most of those standard devices. Okay, so that gives us you know, a lot of freedom when we design application or a system using Raspberry Pi. And it uses little power. This is very important. Nowadays, actually, a lot of IoT applications are deployed. So the most demanded property for an IoT system is low power consumption. Okay, so that's and also it's expandable. That means we can you have a first, if you have a simple system, then you can design a simple system by using Raspberry Pi. If you have a more complex system, you can expand. Yeah. So and because Raspberry Pi uses Linux operating system, so that means it's supported by a huge community of innovators and you know, those hobbyists. Okay, so you can if whenever you have certain problems or you need some kind of programming examples, it's very easy for you to find you know, help from the internet because it's supported by a huge community. So all these are general characteristics of Raspberry Pi devices. And so when we can use Raspberry Pi, it's perfect for integration of high-level software and low-level electronics. So if you high-level software means instead of using assembly language or machine learning, you can use C++, you can use Python. C++, Python, they are considered as high-level software. Okay, high-level software, the problem is it's too far from the real hardware, the circuits. It's not easy to control hardware. However, Raspberry Pi provides this platform. Okay, so Raspberry Pi can do all those low-level electronics problem, and with your high-level software. And so it provides a very unique platform, and also it leverage the Linux operating system for your project, which means this is also very beneficial because you can design. I mean, with the support of Linux system, when you design a program for your Raspberry Pi, it can also be executed on some other platforms, as long as that platform also use Linux. Okay, so this gives us a very unique advantage. For example, if you want to do something, you don't know how to do it, you can just go online, search for certain applications using in Linux. Okay, so you will see a lot of resources. Okay, so you can directly migrate that system, that program into your Raspberry Pi. Okay, and also you can play high definition video. That's very unique. Okay? Because if you are familiar with, for example, Arduino, you know Arduino doesn't have a operating system, so that means you cannot do most of things you can do by using Raspberry Pi. And when not to use real-time application, actually Raspberry Pi, even though Raspberry Pi is an embedded system, but since it's based on Linux, so that means it doesn't support real-time application. Real-time application means you know, the response time of your program is very short. That means we can say, you know, the response of your program should be in real time. Once you input the request to your system, you expect the response immediately. That's what we call real time. Okay, but Raspberry Pi actually doesn't support real time because Raspberry Pi, you know, is based on an operating system, and so operating system will have the problem to assign jobs, you know, schedule your tasks. So the schedule actually takes time. Okay, so that means you cannot expect real-time response from an operating system like Linux. Okay, so that means you cannot directly use Raspberry Pi for real-time applications. However, you can connect Arduino to Raspberry Pi, and we know Arduino actually support real-time applications. Okay, so you can connect your real-time circuits, real-time system to Arduino, and then connect Arduino to Raspberry Pi. So that way, even though Raspberry Pi doesn't support real-time application, but Arduino does. Okay, so this way, actually, you can still design a real-time processing system. But like I've said, we cannot directly use Raspberry Pi to support real-time application, and not ideal for project developments that are likely to be commercialized. Okay. So it's very good for doing research, doing education or hobby. For example, if you want to design a system for your home security system, and that's very good. But if you want to commercialize your idea, it's not a good system to use. Okay, so it's very good for you to make your prototype for your research project, for your education project, for your personal project. Okay. There are all kinds of useful documentations available online for Raspberry Pi. Okay. So, for example, Raspberry Pi Foundation website. So you have this www.raspberrypi.org. So you can go to this website to see all kinds of Raspberry Pi information, documentation, and we have this Raspberry Pi documentation is also in the website. Broadcom. This actually is the chip for the Raspberry Pi. Okay, in fact, this BCM2835 is for the Pi 0. Okay, and this 2836 that's for Pi 2 or Pi 3. Okay, but for this specific Raspberry Pi, I'm using Pi 3. Actually, this is the BCM 2837. Okay, instead of 35 or 36, it's 37. Okay, so you see this one, the middle one. The middle one. This is the CPU for the Raspberry Pi. Okay, and the other side, you see this black chip. That's the RAM. That's the memory, the main memory of for this Raspberry Pi. Okay, so you can see, even though this is a small board, actually it's a computer. So you have HDMI, you have all those USB, okay? And this is for camera. Okay? In my system, I have 4 cameras connected. Okay? You can see and this table actually gives us a comparison of commonly available Raspberry Pi models. So you can see we have Raspberry Pi 3, Raspberry Pi 2, 1, and 0. Okay, so for each of them, they have their specific specifications. Okay, so for example, I mean, like I've said, right now the most current version is Raspberry Pi 4. It's not in this table, but it should be very similar to Raspberry Pi 3. Okay, but for us, because we just use our available Raspberry Pis, which is Raspberry Pi 3. All the Raspberry Pi boards and materials are in the lab room. I'm planning to let you borrow because we have this online format. So it's maybe it's better for you to borrow the the hardware boards, and then you keep it for the whole semester. And at the end of the semester, you can return back to the department. So I will let you know when you can come to pick up your boards. Okay. So we have this Raspberry Pi 3. You can see the price, all the hardware specifications, and you can compare. For example, for Raspberry Pi 3, the memory is 1 gigabytes, okay? And we do have this Wi-Fi, but Raspberry Pi 2 doesn't have Wi-Fi. Okay? So that's that's a very big difference. Okay? For Raspberry Pi 2, if you want to connect to internet, you have to use cable. But for Raspberry Pi 3, we don't need the cable. We can use Wi-Fi to connect to internet. Okay. Okay. All right. So here, this picture actually shows us two examples. We have this Pi 0, okay, and this is Pi 3, okay, Raspberry Pi 3. So let's look at Raspberry Pi 3 because we will use this for our experiments. So this is the CPU. It's the BCM 2837. Okay. If you look at this here, you can see this is here. It's this. Okay. And then, okay, then you can see we have this. This is the Ethernet connector, and we have 4 USB connectors here. Okay. And then we have this HDMI connector, and we have this SD card here, SD card, and this is the main memory chip. And then this is the camera port. It can be connected to the camera, and okay. So from the picture, you can see we have the HDMI, we have the all those things, the connectors, and CPU, and this actually is Wi-Fi control chip. Okay, so the Wi-Fi control chip can control the internet connection. Okay. And so from this circuit board, actually, you can see this is called a PCB circuit board. So for the circuit board, there are a lot of wires on the circuit board. Those wires actually connect all these chips. And the most important part for us to learn is this GPIO. Okay, so for the board here, you see this is the GPIO. So the GPIO actually has 40 pins, 40 metal pins. Okay, so each pin, it provides a certain connection, certain functionality. Okay, so we will see this 40 pins. So here, this table actually gives us the meaning for all those 40 pins. Okay, most of those 40 pins, not all. So you can see we have. Oh no, this is not for GPIO. This actually is a table to showing you for each individual numbered item in this picture. So you have number 1, number 2, number 3 is here, number 4, number 5. Okay, so number 1, that's the processor, and number 2, that's the memory. Number 3 is the storage, which is the SD card. Okay. And then number 6, you see here, number 6, this is the most important thing for us to understand because this provides the interface between the Raspberry Pi board and the external world. So for external world, it means what kind of devices you want to connect to the Raspberry Pi. Okay. For example, if you want to measure the temperature of your room, you have to have a temperature sensor. So then you have to connect your temperature sensor to a specific pin in the GPIO, and then you can write program to communicate with the sensor. Okay, so that's the GPIO. Okay. So the GPIO totally we have 40 pins, and so for these 40 pins, you can each pin it provides a certain functionality. So we will see this in the future. Okay. So for this Raspberry Pi actually it doesn't have a reset button provided. So one possible solution, because Raspberry Pi actually it's a small computer. Sometimes it does the same thing as your general computer. It's just that stuck there. For our laptop or desktop, if the machine is is hot, then we can always reset the system by depressing the power button for certain time, and it will reset the system. Okay, but for Raspberry Pi, actually, it doesn't provide a reset button. So, in the case of the system is stuck there, the only way we can do is to unplug the power cable. Okay, so the power cable is let's see, the power cable actually is connected to this part. Okay, so the only way you can get out from a stuck Raspberry Pi system is to unplug the power. By unplugging the power, actually, sometimes you may destroy the board. Okay? So this is not a good practice. Okay? So to add a reset button may be a good choice, a good solution. Okay? So how to do that? In fact, we can use a button. This button actually can connect to, in fact, on Raspberry Pi board. Let me see. There are two connection points here. Okay, it's here. I mean, once you have this board, you can see. Right now, it's hard for you to see it. It's very small. But those two points actually provides. Is here. So we have two holes on the board. So in fact, you can use a connector like this to solder this connector to these two holes, and then you connect the button through this connector to this two. Okay. So this two, once we short these two holes or these two connection points, it will reset the whole system. Okay. So that's that way. In fact, even though Raspberry Pi doesn't provide a reset button. In fact, we can make our own reset button by adding a connector to provide a possible way to short these two points. Okay, so you can see this is a connector. These two connector can be connected to a button. So whenever you need to reset the system, you can just depress the button, and the system can reset. That way, in case of a stuck execution or a stuck system, you don't really need to unplug your power cable, because by unplugging your power cable, you may destroy your board. Okay. Do you have any questions up to now? Okay. All right. Okay, so for Raspberry Pi accessories, here, we have several Raspberry Pi accessories listed. You will have to use a 5-volt power supply. I mean, you may need this, or you may not. Sometimes you can directly connect connect your Raspberry Pi to your computer. Your computer can provide the power, but it's better to have external 5 volts power supply. And also you have to have a micro SD card. The micro SD card actually works as the memory for the operating system, for the Linux system. So the Linux system actually is saved and installed in the SD card. And then you have to have, I mean, for Raspberry Pi 3, we don't need this Ethernet cable because it can be connected to internet through Wi-Fi. And then you will need the HDMI cable if you want to, because remember, Raspberry Pi is a computer. And that means it can be connected to a monitor, and also you can connect your mouse and keyboard to the Raspberry Pi. So mouse and keyboard, they are connected to Raspberry Pi through the USB port, but monitor, actually you have to connect the monitor through a HDMI cable to the Raspberry Pi. Okay, so that's why we have this HDMI cable. And then you have all this USB to, this actually is for you to debugging the program. USB hub is to provide more USB connectors because the Raspberry Pi itself only provides 4 USB ports. Okay. Actually, we do need for our lab, we do have this HDMI to VGA adapter because most of our monitors in our lab are VGA monitors. So that's why if you go to the lab, you will see we do have this HDMI to VGA adapter. And camera, we have cameras for each Raspberry Pi system in the lab. Okay. Like I've said, in the future, I will let you borrow this and hold this for the whole semester. And USB keyboard and mouse. Okay. And sometimes we can use a case to protect the Raspberry Pi. So the Raspberry Pi connectors, you can see we have this. This is for the SD card, okay? And here, this gives us some examples for connecting the Raspberry Pi 0 through certain cables. Okay? And this is the USB to TTL 3.3 volts serial cable. Okay, so this serial cable actually is connected here, and then it provides a USB connection. So this USB connection actually can be connected to an external device, and then that will be converted into 3.3 volts because USB actually use 5 volts, okay? And Raspberry Pi, most of Raspberry Pi, they use 3.3 volts. So that's, there is a voltage difference. You cannot directly apply 5 volts to 3.3 volts because even though 5 volts is not a high voltage, but directly apply 5 volts to 3.3 devices can result in damage the device. Okay, so that's why sometimes you have to use this kind of cable. But for our experimentations, our lab system, we don't really need to worry about this. Okay. And there are some other USB accessories. Okay, so we don't need this for our system. Okay. Camera, we do have a camera. This is a Raspberry Pi camera. Okay, so we do have a Raspberry Pi camera, and once you borrow our device, you will see there is a camera. Okay, so the Raspberry Pi camera looks like this. Okay, so this is a Raspberry Pi camera, and the camera actually is connected to Raspberry Pi through this port. Okay, so you can see this is the Raspberry Pi camera port. Okay. And by using this Raspberry Pi camera, we can do a lot of interesting projects. Like we can use this camera to take video, and then in real time, we can identify what kind of object it is in your video, okay? Like a person or a desk or something else. Okay? So nowadays, actually, there are a lot of artificial intelligence projects already provide this capability to classify the objects, so we can utilize those to design our own projects. Okay. And also there are some another very good thing by using Raspberry Pi is there are a lot of daughter boards provided for Raspberry Pi system. Okay, so those daughter boards, they are called heads. So this heads board means you can put the board on top of the Raspberry Pi, okay, to expand functionalities. Okay, so very important, very popular headboard is this SenseHead. This SenseHead actually was designed by NASA. Actually, they sent this SenseHead to the space station. So they use this SenseHead on space station to do a lot of experimentations. Okay, and for us, actually, we will use this SenseHead. Okay, so you can see this is the SenseHead. Okay, the SenseHead actually is on top of the Raspberry Pi. Okay, so this is the Raspberry Pi, and this is the SenseHead. So the SenseHead actually is plugged on top of the Raspberry Pi onto the GPIO. Okay, so the GPIO, remember, GPIO means all these pins. Okay, so totally we have 40 metal pins for the GPIO. Each pin provides a kind of functionality. Okay, so this SenseHead actually is plugged onto the top on top of the Raspberry Pi and provide all those functionalities. Okay, so this white matrix actually is a LED matrix. Okay, so we can use this LED matrix to display certain things. We can display a sequence of letters, message. We can also use this board to display something. In the future, we will work on a tic-tac-toe game. So we can use this LED matrix to display the game board. Okay, and on this SenseHead, in fact, there are some sensors. We have a temperature sensor. We have all kinds of speed sensor. All those sensors, and also there is a let me see. Okay. We have this, button. You can do certain things. Okay, so that's very interesting. In fact, by using this SenseHead, we can do a lot of things. Okay, so we will work on several several projects by using this SenseHead. Okay, so we have sensors, we have this display matrix, and we have this the input button for us to input certain things. Okay. All right. So how to destroy Raspberry Pi? That's very interesting, right? You don't want to destroy your Raspberry Pi. Okay. All right. So that means this provides something that you cannot do, or you want to avoid when you using a Raspberry Pi. Okay. So you want to avoid shutting the Raspberry Pi down by pulling out the USB power supply. That's what I said before, right? So that's something that you want to avoid. Okay, that's why in the previous example, they say that we can make a reset button. Okay, but for us, actually, we don't have this reset button. Sometimes we do have to unplug the power supply, but generally you want to avoid this. Okay, and another thing you want to avoid is to place a powered Raspberry Pi on metal surface. And we all know that metal surface will short the circuit, and a short circuit will destroy the Raspberry Pi. Okay, so you want to also avoid that. Okay. So after you borrow the board, you take the board back to home. You have to make sure that you don't want to place a powered Raspberry Pi on a metal surface. So whenever you want to play with your Raspberry Pi, work on a specific project, you want to make sure that you place your Raspberry Pi on a surface without any metal. Okay, so you don't want to short the circuit. And another thing you want to avoid is to connect circuits that source sync other than very low currents. Okay, because Raspberry Pi actually is a low power device. So you don't want to put a large current or voltage onto Raspberry Pi. That will definitely burn your Raspberry Pi. Okay, so make sure that the highest voltage you want to apply to your Raspberry Pi is 3.3 volts. Okay? And connect a circuit that is powered to at 5 volts. That's something you want to avoid. Okay, 3.3 volts tolerant. That's for the Raspberry Pi. Okay, 5 volts. If you apply directly 5 volts to Raspberry Pi, it's very likely that you will burn the circuit. And another thing you want to avoid is to apply power to GPIO header while the Raspberry Pi is not powered on. Okay. And also plug into wrong pins on the GPIO header. So that all those things you want to avoid. Okay. All right. So we actually just quickly went through the first chapter of the textbook. I just spent a very short time quickly go through the first chapter. There are actually a lot of information. So I suggest you go back, download the textbook, and read the first chapter, okay, to fully understand all those basic information about Raspberry Pi system. This Raspberry Pi actually is very useful. It's very interesting. When you go to a senior year, when you work on your senior project, very likely you will use this. So it's better to fully understand the system, and that way you don't need to spend much time when you prepare for your senior design. So that way you can save a lot of time, focus on your real system design. Okay, so in this chapter, actually, we describe the capability of the Raspberry Pi and its CPU ability for different project types. And we describe the major hardware systems and subsystems on Raspberry Pi boards. And we identify important accessories for Raspberry Pi. And we have an appreciation of the power and the complexity of the Raspberry Pi as a physical computing platform. And we learned those actions that we want to avoid without, in protecting our Raspberry Pi.